Thank you so much for having me here. I think it's really an interesting and unique opportunity that we get to interface with students and faculty. I'm here representing the Clinton Health Access Initiative. You'll hear me call it CHI, which is our acronym. And let's see. Okay. So just a little background about who we are. We're a non-governmental organization. We work in global health. The organization was founded in 2002 by Bill Clinton, and we work in about 32 countries. Our organization spans more than malaria, which is what I'm going to talk about today. It began with work in HIV/AIDS, and we now also work in TB, maternal and child health, diarrheal diseases, vaccines, family planning, hepatitis, pneumonia, cancer, and a lot of health system strengthening in terms of health financing and human resources. We also do a lot of market-based work, price negotiation, driving prices down, making drugs and diagnostics more accessible for people around the world who are suffering from those diseases that I was talking about. So I'm going to start with a little bit of an intro to malaria and the field of spatial epidemiology, and then we'll move into some of the uses that we use for maps, understanding where malaria is and isn't, and then also some work that we're doing to guide our operational planning. So for anybody who's here who's not familiar with malaria, or just a quick recap, malaria is an infectious disease. You get it from, it's a parasite that you get from the Anopheles mosquito. A very complex life cycle. We haven't known about it actually all that long. We've only known that it was transmitted by mosquitoes since 1897, and the parasite itself was discovered in 1880. So even though people have been suffering from this disease for thousands of years, our knowledge of it is improving constantly. And then just in terms of the burden of malaria around the world, in the most recent data that we have a complete year for is 2016. So 216 million cases, about 500,000 deaths, and quite a bit of money invested in trying to eliminate it. A lot of this comes from a 2007 announcement by Bill and Melinda Gates Foundation that they wanted to eradicate malaria during Bill Gates' lifetime. And then I keep using the wrong button, sorry. And then you can see where malaria falls in terms of causes of death still, and this is mostly in under 5 children and mostly in sub-Saharan Africa and India. And this is in low-income countries primarily. So for anybody who's not familiar with epidemiology, just a really quick starter course for you. We think a lot about patterns, and we go through like the who, what, where, why, when. So who gets the disease? Do some people get it more than others? Is it men, women? What are the demographics? Is it poor people, affluent people, people of certain ethnicities? When do cases occur most frequently? So is it a seasonal disease? Do people get it more in 1 month or 1 season more than another? And then, of course, where, which we'll go into quite a bit. Is it everywhere evenly? Is it ubiquitous? Is it only found in some places? Is it found in some places more than others? And what kinds of variation do we see in those patterns? Are the same people getting it in different places? Is it always under 5 kids? Is it adult forest workers in other places? So these are some of the types of questions that we ask to try and get to solutions and how to combat the disease. So then we think about, well, why are we seeing that variation? And that'll lead us to a lot of our operational and research questions, and try and help target and use resources as efficiently as we can to combat the disease. So next one is getting more into spatial epidemiology. So spatial epidemiology looks a lot at this where, but it also involves all of the questions that I just talked about. So one of the examples, if anybody's ever taken an Epi 101 class, the first thing that you'll probably learn about is the cholera epidemic in London, and the mapping work that was done in order to realize that the source of that epidemic was from a single pump. This is actually the first time I've really looked at this map. It's quite interesting because each of the black bars is a household where a death occurred. Kind of the first classic example of spatial epidemiology and using mapping in this disease pattern work. Another good example very recently was, you might have seen these posters up in airports recently about Zika. Basically anything that has to do with a map and the sort of heterogeneity of disease in some places over other places falls into this sort of newly emerging field of spatial epidemiology. And then a very relevant example for us is the example of understanding where malaria is. So I'm going to come back to this map. And why do we look at this? Why is it important? Well, you saw that billions of dollars are spent on malaria annually. And we need to know where to put resources. Resources are not available free-flowing. I deal more in the biological ecosystems and the corporate ecosystems. We're driven by lives saved and not by dollars and cents here. So we do a lot of work to try and understand where we can be most efficient and where we can target those resources to make them the most effective. And so coming back to this map of where we need to look, where we could put those resources to most effectively treat the disease. So that's just a little bit of background on the field that I work in and on malaria. And now just a little bit about how we're using the mapping technology. So these are some descriptive maps. And these are some of the ways that we use maps descriptively. They might be, so the first one is Swaziland, and it's a map of household point locations of confirmed and confirmed cases that are local or imported. The second one is an area in the south of Zimbabwe that's at the health facility level. So then we're talking about aggregated case data, not just specific people. And the third one is aggregated up to an administrative area. And so each of these maps provides very different information, and each one has pros and cons that go along with it. Obviously, with the Swaziland map, we have some really great information about where transmission may have occurred, but there are also a lot of ethical issues in terms of privacy of mapping locations of houses where people have these diseases. Is not maybe so much for malaria, but if you think about HIV/AIDS, or some of the very sensitive other diseases, this might not be something that people want out there publicly. Health facility level maps, you also maybe get some information about where transmission is occurring because people are probably more likely to go to their closest health facility. And we can adjust sort of for population density and some other potential risk factors that might be involved. But they may not be the place where people had the transmission occur. And health facilities don't always report their data on time or completely. So there are a number of problems that can occur with health facility reported data. The administrative area is great because it's a really effective communication tool. Where's the malaria in Guatemala? It makes it really easy to see things and really easy to adjust for population as well. But these, we call this in epidemiology the ecological fallacy, where it's smoothing over a lot of heterogeneity and variation within the population. And we may not see the level of detail that we need to. So these kind of descriptive maps, we use them all the time. We share them with ministries of health where we work. Especially maps of incidents, I would say. They're very effective communication tools. We look at a lot of side-by-side comparisons. We can look at changes over time with these types of maps, and we find them very useful for hypothesis generation about what's driving transmission in certain places. Sometimes they miss a lot of the malaria, though. They don't include private sector, which usually doesn't have a lot of reporting. For example, we've been doing a lot of work in India lately where we think up to 80% of the malaria burden is not reported because of so many people visiting the private sector for treatment. And then, we know now that we can capture data on where we have data, basically, and that's what we're mapping. These maps are obviously very biased by where we have data reported and where it isn't. And so the question then becomes, do these actually show where malaria is and where it isn't? Well, I would argue that, yes, this gives us some good information, but it's probably not the whole picture. So one of the things that we've been doing at CHI lately is we've been looking at how we can model transmission of malaria instead of just reported incidents. So the map over here shows exactly an example of the type of maps that we were just looking at. So cases reported either in points or by administrative area, and that's the southern part of Laos that you're looking at there, where it might look from the reported data that malaria is really kind of on the east side. In actuality, I think there are more large-scale health facilities and hospitals there, so they're actually reporting more cases. And then we're moving more to these transmission maps that are showing where malaria is more likely to occur, not just where it's reported. So now we're starting to look at malaria risk factors. And this is where spatial epidemiology is a really great fit with malaria because there's so much about the environment that's related to the disease. It has a very complex relationship with the environment. So we've been working on doing some geospatial modeling where we can predict malaria at a finer resolution. So I want to get a little bit, so that you understand where we're going with some of this modeling, into the risk factors and the environmental relationships that we're looking at here. So the reasons why you see the red spots on the map, have a lot to do with the environment. And so there are places that are suitable for the disease to occur and places that aren't. And you have to have sort of this commingling of susceptible people, susceptible mosquitoes, and the parasites all in one place for transmission to happen. So we're trying to find sort of the intersection of those places so that we can understand better where cases might be occurring most frequently. So some of the environmental factors that we would consider would be temperature and elevation, which relates very much to temperature as well. So the parasite needs to live long enough to be able to complete its life cycle, which means that the mosquito needs to live long enough so that the parasite can complete its life cycle without killing the mosquito. And these are very, very specific sort of intervals of temperatures, so they need to be, like, it can't be less than 18 degrees Celsius, it can't be more than 40 degrees Celsius. So they really need this sort of optimal frame of reference where mosquitoes can live for at least 50 days. There are only about 60 species of anophelines that actually can biologically transmit malaria, so we need to find out where those live, which is some other work that is being done on the entomology side. And those mosquitoes each have their own separate ecological niche. So there are mosquitoes that transmit malaria that will breed in something as small as like a hoof print of water in Africa. And then there are others that may require like brackish water along a coastline. So there's a lot of variability on the side of the vector in terms of what types of environments are most suitable for transmission. And then there's the human side as well. So there are a lot of things that can affect malaria transmission in terms of humans too. So it's generally known as a rural disease. It's mostly where people are exposed to these mosquitoes that transmit malaria. We're finding that land use is becoming more and more important as an indicator of transmission, especially things like irrigated agriculture, extending seasons where water is available for mosquitoes to breed. Malaria is a disease of the poor. It's affluence and things like poor quality housing, like you can see in this picture here, allow for mosquitoes to get in through unscreened windows and open eaves. There might be things like occupation, so women who are out collecting firewood in the early morning hours, or men who are sleeping in the forest because they're working in forested areas in Southeast Asia might be more at risk. And then of course access to prevention and care. So people are disproportionately have access to treatment available, and so the longer they're infected before they're treated, they have more of a chance of transmitting the disease to other people. So a lot of these different risk factors that I've been talking about are available as spatial data sets. We get quite a few of the environmental layers from remotely sensed data. So we use a lot of the NASA data sets. And we have some other surfaces as well. We work a lot with an organization called the Malaria Atlas Project, which is in Oxford University. And they do a lot of modeling for us, and they do most of this transmission risk modeling for us. They also have produced surfaces like this accessibility layer that will tell us the length of time it might take to cross a pixel, given the environment in that situation. And then population density, we get a lot of this from the World Pop organization, which is, has been spearheaded out of Southampton University in the UK. So what we do is we put these layers into a spatial model. And we're not talking about like machine learning or high-level technology here. We're talking about like statistical modeling. And that's how we basically apply all of these layers to understand what the predicted risk might be in each 1 kilometer square. So we basically get a raster surface back out of this that looks something like this. And I think we saw the one from southern Laos before. This is Cambodia, and it's giving us a sense more of not where data are reported, but a value that we can extract for every single place in the country about where malaria might happen and what the predicted incidence might be given the population density and all of these other environmental factors. They obviously have a lot of uncertainty associated with them. They're still only as good as the input, so our response variable is still the predicted or the reported incidence. So even though we're adding a lot of data to the model with all of this environmental and population data, we still only get something back out as good as we put in. So it's very important, obviously, that we also have this on the ground context associated with it. So do people actually live in the place where malaria is predicted, for example? They should, because population's built into it. But maybe it's a place that people only visit seasonally for fishing or something like that. So the models are basically never finished. They can be improved, and we can perform further sensitivity analysis on them. And these are really cool, exciting models that we're doing for, MAP has done for the entire globe, for prevalence, for predicted incidence here. But we know that there's a lot of work to be done on the output side in terms of interpreting the covariates that go into the model, what those coefficients actually mean. So some still quite new work here. So these are the two global models that MAP has done. And these are prevalence models. So prevalence, if you're not in the world of public health, is a snapshot in time. Basically, they go out, people go out and do field surveys where they take blood samples and see how many people actually have the malaria parasite in their bloodstream at the time the data were collected. And so MAP has taken all of the different data points that they can find from all the different studies and published literature and put them together into their environmental models that we just talked about. and created maps for the two primary species of parasite that you find from malaria in the world. So the top one is falciparum, which is the malaria that you hear about killing children in Africa. And the lower one is vivax, which is a different parasite that's less deadly, but can stay dormant in the liver for years and years. And so it's also a big drain on the health system in terms of days of work lost, in terms of treatment, and just resource drain for work efficiency and school loss, days of school loss and things like that. I think that's all I wanted to say on those global layers. So then we can start to zoom in and start to get into how we're using these maps and applying them to our work. This is some work in Guatemala where we're categorizing the risk map based on strata that the Ministry of Health has decided are important. And then we can calculate how many people live in those areas. And it will help them, like this was actually done for costing out an application for the Global Fund for external financing for their program, trying to understand how many people are actually at risk. So instead of covering the entire population of Guatemala with bed nets or something like that, we're actually giving it to people who need them and not people who live in high elevation areas where there is no malaria. And then we can zoom even further. And this is a community in southern Guatemala where we've actually done a spatial join with the risk map, and we can see, like, within actual communities and using the enumeration data, which parts of those communities might be at higher risk, so that if we're going out and doing indoor residual spraying with insecticides, we might know which places we should go first. So now I'm just going to give a few examples of how we're using these maps in our operational work. And I'm going to focus more on the OSM and remote enumeration data and some of our work with HOT. So you saw this morning. I don't know how to do those animations, so I'm glad you already saw it. But this is one of the areas where we've been working. Obviously, I know Tyler mentioned it this morning if you happened to catch his presentation. They've been doing a lot of work for us in terms of mapping structures primarily in southern Africa. And the reason really has a lot to do with this indoor residual spraying, which sounds terrifying, I know. And it gets worse because they use DDT in a lot of places. It still works though. It works to kill mosquitoes when they land on the walls inside, and these female mosquitoes come in the evening and when people are settling down for the night, and it's been shown to be one of the most effective preventative methods for malaria that's out there. So the benefits still outweigh the risks. So we've been using the OSM data, as I just showed you with the community map in Guatemala, to understand where structures are, where people are living in structures that are most at risk, so that we can prioritize where to send these spray teams. So this is basically looking at the predicted incidences using the risk maps that I showed you before, and then on the ground discussions, of course, will inform, does that make sense? Is there a road to that place? Does that on the ground make operationally feasible sense to be prioritizing these places? And that helps with a lot of things, like when we do have heavy private sector use, where that that maybe all of the malaria in a place is being missed by the reported incidents. So we use it for targeting and prioritization, and it's also being used on the monitoring and evaluation side. So it used to be that these spray teams would report their coverage and how well they're doing by saying the number of rooms that they sprayed out of the number of places they visited. Well, who knows what that denominator is? So using an actual metric of how many enumerated structures are on the ground and then how many were visited is a much better way to assess whether a community has been fully covered by the intervention. A second way that we're using this type of data is, this is a map of Panama. This is the Gunayala comarca on the Atlantic coast, and one of the last places in Panama that still has malaria. They've done some really extensive community mapping through their census work, and we're now using that to number houses and build it into their new surveillance system. This is very important because this is a vivax malaria, primarily transmission area. And in order to block transmission for vivax, you need to take a drug for 7 to 14 days, which is very difficult to get people to do because they'll start feeling better after the first couple of days when their fever has subsided. So this is really important for community health worker networks to be able to know which houses they've been to, which houses they need to follow up on, and also to track where cases have occurred. The third example has to do with transmission risk factors based on case locations at a very small scale. So now we're looking at things like if you've ever taken a spatial stats class or some GIS work will do this also, we're talking about spatial clustering. So are diseases happening more in one place or around one place than another? So kind of the John Snow example of cholera cases around the water pump. So this is part of some case control work in southern Guatemala that we've been doing. And it's more kind of led to hypothesis generation than anything else, but it can kind of, using these communities, we can sort of start looking at other things that are existing around there. So, so water features, places where mosquitoes might be breeding. Where's the health center? Is it open? Where does the community health worker live in this place? What's the transportation network like? And we call that foci investigation in the malaria world, but basically going and doing almost what you would say is an outbreak investigation, even though it's something that happens annually or constantly depending on where you are. But really trying to understand what's driving transmission there so that we can go in and hit that target. And then something that I've been pretty involved with lately is just trying to understand these spatial denominators. So this has to do with more like program level monitoring and evaluation. Is malaria being reduced? Has it been eliminated already? And to do that, we need to understand communities and we need to have a common denominator. So we might have, this is still the same area in Guatemala where we have cases being reported by locality. We have points for those localities, but the points don't necessarily correspond at all with the community shape or the community environmental features. And so we may have bed nets being distributed or IRS being done, and they're all being reported and done at different levels. And so we're trying to understand what these communities actually look like so we can use that shape as an operational unit to track change over time. So we would know what the prevalence is and the incidence is in each one of these little polygons. And these polygons are made by clustering together the houses and the enumerated structures that make up those communities. This is very, very preliminary work that we're still trying to figure out kind of the best way, how to validate this on the ground. Working with a lot of, we have a lot of community work, I think, that needs to be done to validate this. But it's clearly going to be an improvement on the first pass, which I did last year with this grid system, which is just not biologically the way things are. So it's useful maybe for tracking a few things over time, but in reality and in terms of like things that we worry about, like health facility catchment populations, where people are seeking care, where there are gaps in the system in terms of surveillance or case management, it's not very useful, and we need to know what communities actually look like. So just some of the things that we're also working on going forward. The operational unit work is quite big, but this is actually just sort of a shout out back to the Botswana project that's going on this week, where we're doing some on the ground validation work to understand whether structures are truly places where people live, and how many rooms they might have in them. These are important things for us in terms of trying to understand how much insecticide to purchase or to put into grant applications for spray teams. So just that's, and then I just wanted to leave you with this one. Why are we doing this? Well, the reason why we're doing all this operational work and planning is because we've seen time and time again all over the world that if you take your foot off the gas with malaria, it comes back. It's happened after, mostly after IRS programs have stopped happening, but there are many, many examples of this throughout the world. And so I just have some acknowledgements here. And we work a lot with the Gates Foundation and the Global Fund and these universities that I've been talking about, who do a lot of this mapping and working on mobility and human movement with us. And then I know a lot of you, my co-presenters here, have been working with my colleague Caitlin Woolheater. So she's been really deep into this work, and I just wanted to give a shout out to her as well. And that's all I have. You guys have any questions?
This is really, really impressive work.
Thank you.
So I'm wondering, it looks like you were talking about spraying inside the homes. Do you find that method is the most effective, or is it also kind of spraying intermittent ponds in population centers as well, kind of a combination of the two? Or?
So the answer, of course, is it depends. No, it depends on the ecology of a certain area and what's happening there. So yes, there are places where we call it larval source management, where we'll put chemicals or introduce like predatory fish species. There are all kinds of different ways of dealing with that, of trying to combat the larval stage of the mosquito. And there are some places where that makes sense. Like was just telling Tyler last night, I've been working on trying to map some of those larval habitats in Guatemala, where they have above ground irrigation ditches. And we think that that's related to the transmission that's continuing in that specific area. There are other places where the mosquito behavior drives, the adult mosquito behavior drives where we put interventions. So if we know the mosquitoes are biting between like hours when people are sleeping, then insecticide treated bed nets are usually the most effective if people are willing to use them. IRS is particularly effective in places where biting happens, like during dinner time or in the early morning when people are up and about in their houses but not going to be asleep under the net. Mm-hmm.
Thank you for going into the details of how you all are applying mapping technologies to inform the decision making around ending malaria. I'm wondering, I don't know how many people that you have with the analytical capacity as part of CHI, but I'm wondering if CHI operates part and parcel now with geographic information and has adopted that as a very informational tool for making decisions writ large across the organization, or is it just this one particular group of people that you work with?
That's a good question. I would say it varies throughout the organization. It varies throughout which disease we're working with. Malaria has particularly the spatial component has become very popular in the last few years. And I think it just makes sense with all the environmental variables that affect transmission. I've seen some work in some other disease areas. I think like in the diarrheal diseases in terms of access to care, but I have not seen the extent of work like this type of robust spatiotemporal modeling going on with a lot of other disease areas, at least with CHI. Yeah.
So I have two questions, and I will ask them to you one at a time, so you don't have to remember them both.
Thank you.
The first question is, how do you communicate the results from the analysis that you're doing with other donors and local governments and people that are working on malaria projects in the same countries that you all are working?
So the way that CHI works is we have a lot of people embedded within ministries of health, and and by that I mean like literally their desk might be in the office. And so many of the requests that we have for this operational planning work are coming from within the ministries, which is really great. I think it's a really great way to operate, to be answering questions that they're asking locally. And so the communication that comes back to them is very fluid. It's not wait 12 months while we do this and publish it and then we'll get back to you. It's more of a day-to-day conversational process, I would say. On the donor side, it would be a little bit more like periodic updating, but I think that's where this like operational units kind of work comes in very strongly in terms of the programmatic monitoring and trying to identify gaps and trends at the sort of a global, going across all the regions and countries we work in level.
And the next question has to do with that critical environment that you said a mosquito needs to have, a certain temperature, humidity, et cetera. Are you using how frequently are you using like remote sensing and weather pattern data to monitor that as it shifts from year to year? And are you using any type of predictive modeling to estimate where the spread of mosquitoes may end up?
That's a great question. Not yet. I think more and more. I know there's a group called, I can't remember what they're called, but anyway, it's more entomology related. I'm not an entomologist, but they are doing predictive modeling, at least for where mosquito breeding habitats are occurring. I know that work is going strongly in Haiti right now, and they're developing those models. I think the ones that I presented here were kind of the first step. Some of them don't actually even include vectors, and so there's a lot of room for improvement there. So yeah, good. We're talking about like potential research projects. I think that's the water, the irrigation, relating back to agriculture and these types of things in microclimates are really going to be important questions as we get to like the last few cases in some of these countries that are almost approaching elimination. Can I say one more thing, because I forgot to do my pitch. We are expanding, and I just want to say, like, especially if you're a Spanish speaker, we really, really need people in the Americas to help with this type of work going forward. We're actively seeking them, and so yeah, go on our website or talk to me. Yeah, I think we're looking for people with analytical skills. We take a lot of different types of skill sets. Like we'll have people who are MBAs who are doing price negotiation with pharmaceutical companies. We'll have people like me who are much more science nerdy, who do a lot of this like epidemiology work. And then we have people who do sit within I work from the US, but we have a lot of people who work within those country governments, so it's a great opportunity if people want to live abroad too.
Mappers?
Yeah, I think more on the analysis side. Yeah, mostly. Yeah.
Great opportunity there. Thank you so
Yeah.
much. I'm glad we did
Thanks.
that pitch.
Yeah.